Hello everyone, I hope you're doing well. I am Aksha Dubey and I will be completing my bachelor's degree from Bennett University. I have worked on a wide variety of projects that have allowed me to put what I have learned in the classroom into use in practical sense. Last semester, I was part of various hackathons where I managed to experience a lot of things, and it was really exciting to see my portfolio grow. I pride myself on being detail oriented, analytical, and self driven. As a part of the procedure for the course of seminar on special topics in emerging areas, I have chosen wireless body area network as the topic of my seminar. Over the past years, a booming interest in comprehended in the field of wireless communication for the development of a monitoring system to observe human vital organs activities remotely. Wireless body area network is such a network that provides continuous monitoring over or inside the human body for a long period and can support the transmission of real-time traffic such as data, voice, video to observe the status of vital organs functionalities. Wireless body area network is a wireless network of variable computing devices. The body area network field allows inexpensive and continuous health monitoring with real-time updates of medical records through the internet. V-band is a special purpose sensor network designed to operate autonomously to connect various medical sensors and appliances located inside and outside of human body. As the demand for universal network is increased, the devices for home, office, and other information devices that can be communicate wireless in short range have been getting more efficient and more attention. The standard and technique development of universal networks has rapidly put itself into the world market. So V-band is becoming a special application of such a technique. So now we will discuss about the architecture of V-band. The first section is the V-band part, which consists of several numbers of sensor nodes, and these nodes are cheap and low power nodes with inertial and physiological sensors strategically placed on the human body. All the sensors can be used for continuous monitoring of movement and vital parameters like heart rate, ECG, blood pressure, etc. The next section is the coordination node, where the entire sensor nodes will directly connected with the coordination node known as a Central Control Unit (CCU). The third section is the V-band communication, which will act as a gateway to transfer the information to the destination. The last section will be a control center consist of end node devices such as mobile phone for messages, PC for monitoring, and email and server for storing the info in the database. The protocols developed for W-band can span from communication between the sensors on the body to communication to a body node to a data center connected to the internet. Uh, it is divided into two parts: intra-body communication and extra-body communication. A wireless medical sensor should satisfy the following main requirements such as variability, reliability, security, and interoperability. Variability is to achieve non-invasive and unobtrusive continuous monitoring. It is a very important issue. These sensors must be lightweight and small. Size and weight of sensors are mainly determined by the size and weight of batteries, but a battery's capacity is directly proportional to its size. Reliable communication in W-band is of paramount importance for any W-band application. So the designer should target a reliable communication technique which will ensure uninterrupted communication and optimal throughput. For security, it is another important issue. All the wireless medical sensors must meet the requirements of privacy and should ensure data integrity and authentication. And for interoperability, wireless medical sensors should allow users to easily build a robust WBAN. Standards governing the interaction of wireless medical sensors will help vendor competition and eventually lead to a more accessible system. Now, as V-band is a short-range wireless network, so different types of wireless short-range technologies can be involved in a different stages. In this segment, we will describe the most common technologies such as Bluetooth, Zigbee, Wi-Fi, IEEE 802.15.6 that can be used to deploy a W-band. Bluetooth is an IEEE 802.15.1 standard commonly known as WPAN, Wireless Personal Area Network. Bluetooth technology was designed as a short-range wireless communication standard anticipated to form a network with security and low power consumption. A typical Bluetooth network forms a piconet where a Bluetooth device works as a master and another 7 Bluetooth devices works as slaves, which gives each device to communicate with each other simultaneously. Bluetooth devices operate in the 2.4 GHz ISM band, utilizing frequency hopping among 79.1 MHz channels at a nominal rate of 1600 hops per second to avoid interference. Now, Zigbee is an IEEE 8.2.15.4 standardized solutions for wireless telecommunications designed for sensors and controls and suitable for use in harsh or isolated conditions. One of the biggest advantages of Zigbee network is its low power consumption. Zigbee is aimed at RF applications that require low data rate, long battery lifespan, and secure networking. Through the standby mode, Zigbee-enabled devices can be operational for several years. Zigbee-based wireless devices operate in 3 different frequency bands such as 868 MHz, 915 MHz, and 2.4 GHz. Therefore, one substantial drawback of using Zigbee network for W-band application is due to interference with wireless local area network WLAN. Now, Wi-Fi. It is an IEEE 802.11 standard for wireless local area network WLAN. Generally, Wi-Fi technology comes with 4 standards that runs in ISM band 2.4 and 5 GHz with a modest coverage of 100 meter. Wi-Fi permits users to transfer data at broadband speed when connected to an access point or in an ad HOC mode. Wi-Fi is preferably suitable for large amount of data transfer with high-speed wireless connectivity that allows video conferencing, voice calls, and video streaming. An important advantage is that all smartphones, tablets, and laptops have Wi-Fi integrated. However, the main disadvantage of this technology is high energy consumption. Now, IEEE 802.15.6, which is the latest addition in WBAN, which is known as WBAN standard that provides various medical and non-medical applications and supports communications inside and around the human body. This standard supports communication inside and outside of the human body, which can be used for different medical and non-medical applications such as e-healthcare monitoring, sports environment, etc. Now, As like other wireless networks, W-band is also capable of transmitting data, voice, video, picture, etc. through radio transmission path. For this reason, W-band has introduced several numbers of innovative and effective applications. Broadly, these applications can be categorized into two categories. Uh, they are medical and non-medical applications. W-band has conquered the medical area with a wide range of possibility. The technology is improving the efficiency of doctor-patient activities such as remote patient monitoring, timely health status notification, emergency calling, etc. From anywhere and at any time. Some potential applications are remote healthcare monitoring, assisted living, and telemedicine. And talking about non-medical applications, uh, they come under sports, military, lifestyle, and entertainment. For the conclusion, we have discussed that it is an emerging technology which is expecting to have a great impact on the society and uh, in the field of medical and non-medical sector. So, in this seminar, uh, an overview of W-band has been outlined where we have highlighted the W-band architecture and deploy requirements of this technology. We have also discussed about development and the technology adoption with different fields of application here. The aim was to offer a suitable and appropriate wireless technology in order to deploy network. For this reason, we have described several short-range wireless communication technology that can be adopted in W-band. So, in the end, I feel that several non technical factors would also play a crucial role in the success of W-band technology development, such as affordability, legal, regulatory, and ethical issues, and user friendliness, comfort, and acceptance. So, that's all from my side. Thank you and have a nice day.